Hello, lovely people. What is up? Today we are solving a problem called isomorphic strings. So this question is from the POTD series of GeeksForGeeks website. In this question, we are given two strings S1 and S2 consisting of only lowercase English alphabets that are equal in length. We have to check if these two strings are isomorphic to each other. So basically, two strings are isomorphic if characters in one string can be replaced consistently to get the other string. The order stays the same and each character maps to only one character and no two characters map to the same character. So for example, let us say string 1 is egg and string 2 is add. So if we map E to A and G to D, the pattern will look like ADD, which is ABB, and ABB, which has the same structure, which is isomorphic. Now let's take another example, S1 and S2, S1 being FOO and S2 being bar, BAR. If we match F to B, A to O, and again we can't match A, O to R because there will be conflict, and one letter cannot be mapped to two different letters, so it is not isomorphic. So to solve this problem, we can apply the logic of maintaining a two-way mapping. So what is a two-way mapping? S1 is mapped to S2 is forward mapping and S2 mapped to S1 is reverse mapping. So when we do this and AND both the things, this guarantees unique values. So think of it like pairing dancers. So A is always with X and B is always with Y. We cannot pair A with both X and Y or vice versa. So to apply this two-way mapping, we can use two dictionaries. Map 1 where forward mapping happens and map 2 where the backward mapping happens. So as a first step of coding, we have to create two hash maps. So think of it like having English and French dictionary. The English to French translation should match the French to English translation. And then in step 2, we should traverse both the strings together. So instead of separately indexing it like for I in range of length of S1, we can do it like for C1 and C2 in zip of S and T. And as the third step, before inserting the mapping, we have to check if the character already has been mapped somewhere else. And then again, we have to verify the opposite direction. Finally, if it passes both conditions, we store mapping. And then we continue this process until the end. So now let us take a look at the code. We define two maps. Let us name it map ST and map TS. We declare the maps or the hash maps using curly brackets. Now we use the for loop for C1, C2 in zip of S, T. So zip is a built-in Python function that combines multiple sequences together element by element. It basically pairs items based on their same index position. So then we initialize an if statement stating if C1 in map ST and map ST of C1, which is the current index of map ST, is not equal to C1, we return false. This is checking if the forward pass current character is mapped to any other character. Now similarly, we have to check the backward pass. So we write another if statement stating if C2 in map TS and map TS of C2 is not equal to C1, return false. So then if both these conditions pass, then we add these characters to the map and map them. So map ST of C1 is equal to C2, and in the next line map TS of C2 is equal to C1. And finally outside the loop we return true. So now the time complexity of this particular problem is O of n linear time, because inside each iteration we do hash map operations, and hash map operations in Python are constant time, and since we run the loop n times and O of one time complexity n times create O of n linear time complexity. So as you can see, the code runs in the most optimal time possible. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye guys.